Good day. Micro Long Range FPV drones have burst onto the scene with the Dave C. inspired Flywheel Explorer LR. Everybody wants one, whether it's the digital Caddx Vista version or the less expensive analog version. The problem is, though, when you order one, it could take months to arrive, or it's simply not available. No worries, though. You don't have to wait anymore. You can start flying your Micro Long Range FPV drone a lot sooner just by building it yourself with components that you can get right now. Today, I'm going to show you how to do just that. Really, all it takes is the right battery, the right motors, and of course, a lightweight micro FPV frame like the Airblade Transformer from Airblade UAV. Today, though, I'm going to show you how to build your very own Micro Long Range FPV drone using the versatile, lightweight, and durable Diamondback Rattler frame. You can use it for long-range flights or shorter-range flights with really long flight times. That's right, I'm going to show you how to build the extended flight version of the Diamondback Rattler, the Rattler XF. This is going to be fun. Make sure to hit that thumbs up button below and subscribe to your TMac FPV channel, your home for your journey to better FPV fun, flights, and racing stuff. Alright, here I've started to build my Rattler XF extended flight quad, and what I've done so far is I've placed the ESC on the base plate using some 5mm spacers to keep it as short as possible. I'm using 20mm standoffs as opposed to the normal 25 on the Diamondback Rattler. Because I'm not going to be using a split type camera or my normal Tarsier, what I've decided to do is I'm going to use the dual stack mounting pattern of the Diamondback Rattler, but I'm only going to place one board on each stack. So I'm going to have the ESC in the back and the flight controller in the front. And that way I can keep the profile as low as possible with plenty of space in between the ESC and the top plate to fit my VTX and have a lot of airflow in between the ESC and the VTX to keep the VTX cool. And same thing between the flight controller and the receiver on the front stack. So normally this Diamondback Rattler frame is built for a split type camera for dual stack configuration. In this case, I'm just taking a single stack and splitting it up into the dual stack mounting patterns. I've tinned the ESC pads for the motors as well as for the power leads, and I've built my XT30 power lead connector to include this waffle XT30 and capacitor board, which makes it a very neat build with the capacitor right next to the XT30 connector. It also makes it more durable so your capacitor leads aren't bending back and forth every time you land or bounce your quad off the ground. So I've got my capacitor and XT30 connector attached to this waffle board. These come in both sizes for XT30 as well as XT60. I'm using 16 gauge wire, and I've connected the power leads obviously to the ESC. Now I'm going to mount the motors on the motor pads and measure the wire lengths to the ESC and cut the wires to length so that they lay neatly along the arms. And then I'm going to solder the motor wires to the ESC pads. I found works best for me to measure the length of the wires needed to run to the ESC is to run the motor wires neatly along the length of the arms, and before you cut them, I've taped them down with this Emax fabric tape right next to where the motor wires meet the motor. Not too tight because you don't want to pull them out of the motor. Do that first and then continue to run the wires along towards the main plate and tape them down close to where the arms meet the main plate. And then from that point, run the wire up and snip the wire off just so that the bare end of the wire after you pull part of the sleeve off of it is laying flat on the ESC motor pad. And then take your angled snippers and cut the wires, pull a little piece of sleeve off the end of the wire, tin the wires, and then just solder them up to each of the motor pads. I've gone ahead and done that obviously with this first motor, and I'm going to do the same thing with the other three. So before I go any further, one of the things that's making this Rattler Flat XF for extended flight quad able to fly long flight times, the main reason are these Airblade 1404 2500 kV motors. I'm going to run these off of 4S, and these Airblade 1404s are very efficient motors, even with a higher kV, and at this kV, 2500, keeping this build as light as possible, this thing should get quite a bit of flight time, extended flight time, XF type flight time. So on these front arms, what I'm doing, just like the back, I'm running the wires along the arms and taping them down with this Emax fabric tape near where the motor mounts to the pad, and then also near where the arm meets the main plate. But on these front arms, what I've decided to do to keep it as neat as possible is to run the motor wires underneath the ESC behind the standoff spacer. So they're going underneath and behind the standoff spacer, and then they're coming up from the bottom, and I'm going to cut the wires so that they meet the pads right here. And that'll keep these wires from catching on anything during flight out of the way, and a nice neat build. All right, here's what all the motor wires look like, all taped down, running along the arms, wires cut to length, and the ends soldered on their ESC pads. Turned out pretty good. Another thing I wanted to mention that I've done in order to save some weight is normally the motors are mounted with 4 screws. I've purposely left out 1 screw, so I'm only using 3 screws on each of the motors to save a little bit of weight. So that saves 4 screws, maybe a gram or 2. Now what I want to do is I want to take my old school smoke stopper and make sure that the motors and the ESC are working properly at this point and that I don't have any shorts. I've checked it visually and it all looks good to me. In fact, on this Mamba 306 ESC, by the way, the flight stack I'm using is the Mamba F722 Mini flight controller. And I'm going to F7 flight controllers whenever I can. That way I don't have to worry about inversion on receivers if I decide to use a different receiver other than a Crossfire. This is the Mamba F722 Mini. And the ESC that I've chosen to go along with this is the Mamba MB306 BL Heli 32 ESC. So I'm going to be able to run RPM filters on this without installing any special ESC firmware. So right now I want to do that old school smoke stopper check. If this light bulb lights up, we have a problem and we need to stop and figure out what it is and fix it. If this light bulb does not light up when I plug in the LiPo, then we're good to go. And you should hear a couple tones from the ESC. That's good. That means we don't have any shorts and our soldering and wiring is good so far and the ESC is working good. The other thing I do when I check this out is I want to check each of the motors. To do that, all I need to do is hold my fingers gently on them when I plug in the LiPo, and you can actually feel the motor vibrate slightly when you plug the LiPo in. That tells me that motor is working properly. That's good. And that one's good. So we're good to go. All 4 motors in the ESC seem to be working fine so far. So now I'm going to tin the pads with a flight controller so I can connect my components to it. And I'll be using the Mamba F722 Mini Mark II wiring diagram, which you can pull off their site. I'll leave a link to it down in the video description below. Okay, I've tinned all the pads that I'll be using, and of course I'll be connecting my FPV camera to the flight controller. I'm also going to be using a GPS module. I'm going to connect my Crossfire Nano receiver, a full speed RC Lucky Box buzzer, and my EWRF E708 TM3 Pro video transmitter that has settings of 25, 200, 500, and 800 milliwatts. The FPV camera I'll be using is the Foxeer Predator Micro V3. And the way I installed this flight controller is I just inserted the gummies into the mounting holes, and that's all I used to keep a low profile on this build. I've just got the gummies resting up against the base plate and the flight controller resting on top of the gummies. Looking good so far. All right, here I've got all of the components wired up to my flight stack. And before I buttoned her up, I wanted to show you what I've done. To begin with, as I've mentioned, I've got the Mamba F722 Mini Mark II flight controller along with the Mamba 306 BL Heli 32 ESC. So on this Micro Long Range FPV quad, the RATTLER Extended Flight, or XF, I will be running RPM filters on it with bidirectional D-shot with this BL Heli 32 ESC. All of these components I've attached, I've done my best to run the wires underneath the flight stack. All the wires, to the best of my ability, are sitting on the base plate below the flight controller and ESC. And I've got sufficient room, even with this low stack profile, between the base plate and each of the boards to run the wires without interfering with the flight controller or the ESC. I've incorporated, to the best of my ability, as much of the stuff that I've been doing videos on as possible, to include using the Maytech SAM M8Q GPS module powered with this isolated power supply of the iFlight 5-volt regulator. Now, one thing you need to know about this iFlight 5-volt regulator is I do not believe it's got overcurrent protection, whereas some of the others, the Pololu and the Maytech regulators, do. So those might be a better option for you so that you don't fry your GPS modules. However, with these Maytech GPS modules, these seem to be working fine with the iFlight version. If you missed the video on how to do the isolated power supply along with the U-Block's assisted GPS, go ahead and check it out through this video, available through a link down below. I'll be using the EWRF E708 TM3 Pro video transmitter, which I mentioned earlier. It goes all the way up to 800 milliwatts. So you could fly this long range if you want to with that 800 milliwatt output power. I've attached it to the top plate just with some Velcro, some industrial strength Velcro. You can also use double-sided tape. I put one side of the Velcro on the bottom of the top plate and the other strip on the VTX itself. So this just gets stuck right up here and it's easily removable. I'll be using the TBS Crossfire Nano receiver, which is my norm, and I'm going to hook up the Immortal T antenna to it like so, and then put some shrink wrap over it to protect both the receiver and also to keep the antenna on the UFL connector. The way I'm going to attach the Immortal T antenna to the quadcopter is through the RATTLER's mounting holes, which were originally designed here for a bracket camera mount. However, since we're using the custom 3D printed camera mount, we're not using these mounting holes for anything else. So I'm going to take this Immortal T antenna, stick it up front like this, run a zip tie through here, across this way, and then also run a zip tie from this front diamond through this other diamond this way. So it's going to be held in place by two zip ties. And the elements themselves aren't going to be touching any carbon fiber. So this is a perfect spot on the RATTLER frame for your Immortal T antenna. Now, as you can see, I've run the battery strap for a bottom mount battery. However, you can run it as a top mount battery too. In fact, it's actually easier to run it as a top mount battery. I'm just used to running bottom mount batteries, so this is just the way I do it. One of the advantages I like about running bottom mount batteries is it clears the entire top plate for whatever else you want to carry on top of it, like a naked GoPro, Insta360 Go, both if you wanted to, whatever pops into your head. I just wanted to point out that even though I'm running it as a bottom mount battery, it's actually much simpler and easier to run the battery strap around the top plate and use a top mount battery. I'll be using, as I mentioned, the Foxeer Predator Micro V3. It's just a camera that I've had sitting on my workbench for quite some time. Figured I'd give it a shot. Normally what I'd like to use is the Caddx Rattel, but this should work out nicely. One other thing you may have noticed as I'm speaking about this is this RATTLER Extended Flight Micro Long Range FPV Quad has got a special feature which others you've seen may not have, and that's this Max 4466 adjustable gain microphone. Now, if you haven't had the opportunity to experience the joy of flying with live audio, I've got a video on how to set that up, which you can check out through a link in the video description below. I've got this adjustable gain mic attached to the audio input of my VTX. And there's not a lot of video transmitters around that have audio inputs, but I've got a video on this EWRF E708TM3 Pro you can also check out, which I believe has a diagram of a few other transmitters that also have audio inputs that you can use to attach external microphones to. Oh yeah, one last thing. Similar to other micro long range FPV quads, the RATTLER XF also has a self-powered buzzer, which is my full-speed RC Lucky Box buzzer, which, once again, I normally use on all my builds. So this is nothing special on this build, and I use it on all of mine. If your battery gets ejected or runs out of power and your quadcopter is lost in tall grass or in the woods or something like that, this has got its own internal battery, which you can program to beep at different rates and for different lengths of time, up to, I believe, 12 hours, which should give you sufficient time to find your quad, especially with how loud this is. So those are all the features and components that I've attached to the RATTLER XF Micro Long Range FPV quadcopter. Let's go ahead and button her up. I'll set her up in Betaflight and show you that. And once again, how I connected all these components together will be available in a video description below with this Mamba stack wiring diagram. Let's put her together. All right, and here's what she looks like all put together. Turned out pretty nice. This is your RATTLER XF Micro Long Range FPV quad for extended flight. Crossfire antenna attaches nicely to those diamond cutouts and the camera mounting holes. I picked this narrow LiPo strap up from Race Day Quads or RDQ. Buzzers attached to the bottom of the 3D printed GPS mount using double-sided tape. And this is an iFlight Sigma VTX antenna. I may actually swap this out with a Lumineer Micro Axie 2. The only thing she doesn't have on her yet is the props, but I don't want to put those on until we do the Betaflight setup, which we'll go ahead and do now. Let's go! All right, let me quickly show you how I set up the RATTLER XF Micro Long Range FPV drone in Betaflight. First of all, the Mamba F722 Mini flight controller has 6 UARTs. I've got the Crossfire receiver set up on UART 5. I've got the EWRF E708TM3 Pro VTX set up on UART 3, which is running TBS Smart Audio. And I've got my Maytech SAM M8Q GPS module set up on UART 4. Configuration wise, first of all, I'm running my motor direction as reversed. As with all my builds, I do have bidirectional D-shot enabled for Betaflight RPM filters. And if you need a refresher on how to set up Betaflight RPM filters, check out this video through a link in the video description below. D-shot 600, 8K, 4K. I've set my arming to 180 degrees. That way it'll allow me to arm the quad even if it's setting up at an angle at the top of a tree. I've got my RATTLER XF craft name. As I mentioned, I've got serial-based receiver and crossfire. I've got my D-shot beacon configuration set to tone 3. You can set these to different tones that you might like. I happen to like tone 3, and I've enabled it for RX set. I've just left all these at default, and as I mentioned in our ports tab, I've got the GPS module installed. The protocol I'm using is uBlocks. I went over that uBlocks configuration software in this video if you'd like to check that out. My ground assistance type I've set to North American. Power and battery I've left at default. My failsafe I've set to GPS rescue with these parameters, specifically sanity checks at failsafe only, and I have enabled allow arming without fix. I've set my minimum satellites to 5. If you need a refresher on how to set up GPS rescue, check out this video on Micro FPV Betaflight GPS rescue. With regards to PID tuning, I've basically left the PIDs at their default values. However, I've disabled D-min. Now I have set up 3 different PID profiles. Profile 1, 2, and 3. Profile 1 is for my normal freestyle flight, which yes, you can accomplish with this RATTLER XF Micro Long Range FPV drone. Profile 2 is for capturing HD video, and Profile 3 is for cinematic flights, such as with our naked GoPro. If you're not sure how to set up these different PID profiles, check out this video on Micro FPV Tuning Guide, Custom Flight Profiles. I've also set up 3 different rate profiles, 1, 2, and 3, which you can see here, basically low, medium, and high. And my rationale for doing that, along with how to accomplish it, you can check out in this video on FPV drone rates. My filter settings are here. As I mentioned, I do have the gyro RPM filter enabled, especially with this Mamba 306 ESC running BLHeli 32 firmware. These are my modes and how I've set those up. This Mamba flight controller does have black box capability, which is nice for tuning. And if you'd like to learn but are unfamiliar with how to use black box, check out this Black Box Basics video through a link in the video description below. On the Adjustments tab, I've got 3 different rates. You select as rate profile selections. I've got those on a switch, low, medium, and high rates, which we just went over. I also have 3 different OSD profiles set up on a switch. These are my OSD profile settings for profiles 1, 2, and 3. The one thing that I have enabled, which I normally do not for the first couple profiles, is my throttle position, which is here, because I'm just interested to see the hover point or at what throttle level my Rattler XF is able to hover at. Video transmitter, I mentioned I've got the EWRF E708 TM3 Pro, which is running smart audio, and I've uploaded the VTX table associated with that here. It does go up to 800 milliwatts. And that's it for our Betaflight settings. And this is what she looks like with her props on. I'm using bi-blades here because bi-blades tend to be more efficient, and we do want our Micro Long Range FPV Quad Rattler XF to have extended flight time. Also, remember the Diamondback Rattler is a hybrid frame, which means you can run 3-inch props up front and 4-inch props in the rear, which is what I have here. Now you may ask yourself, why on earth would I do that? Because I can, and it's fun. All right, before we take her out on flight, let's find out how much she weighs. Dry weight, 141 grams. Nice. How about with a 650 4S LiPo? $202. How about with an 1100 3S LiPo? $209. How about with a naked GoPro? $237. Sweet. And with an 1100 4S? $231. Looking good. All right, I'm not going to show you the complete flight for our Micro Long Range FPV Quad Rattler Extended Flight XF version, but instead what I'll do is I'll fly it both with and without the naked GoPro using the 650, the 3S 1100, and the 4S 1100 batteries, and I'll put the flight times for all of those flights in my pinned comment in the video description below. It's fly time! That's how to build your very own Micro Long Range FPV drone, the Rattler XF, for extended flight time. Long flight times, lots of features, and the components are available right now. What are you waiting for? Let me know in the comments below how you plan on building your Micro Long Range FPV drone. Till then, thanks for your time. I'll see you next video. Clear skies, friend.